More things arrived, including electronics. And, ooh, judging by their very dark color especially, and characteristic look, I would say these are infrared detectors. 20 pieces of 5mm 940 nanometer infrared receiving LED lamp, 99 US cents from King Electronics 15. I've never really played around with these, but I've seen circuits with them for a long time, and I thought, I'm gonna try putting these to use. Maybe I can learn something, maybe I can think of a little application. If nothing else, I'd like to learn more about them. Maybe I can find an old spare remote control and use it as a controller for a project if I can detect and decode those signals with this. This is iron. So, what have we got here? Oh, iron core toroids? Ooh, either I ordered these a really long time ago, or they were packaged a long time ago. So these are partly colored red on one side. 5 pieces of iron powder toroid core T30-2, $1.06 from 9CN7748. These have one side colored red, and the outer diameter is 7.8 millimeters, inner 3.84 millimeters, and a height of 3.25 millimeters. High saturation magnetic flux density, able to work in a large current. Excellent frequency characteristics, high temperature characteristics. I think they're trying to say it doesn't emit a whole lot of noise compared to other structures. Well, no matter, we're just playing around with these on the bench. I've been ordering various sizes of these, so I think I've received enough thin copper enameled magnetic wire that I can actually start winding some coils and experiment with stuff now. This is resistances. I don't know what it is. Resistances, it's integrated circuits. CMOS chips, CD4002. 5 pieces of CD4002 for $1.95 from Orchid. The 4001 being a quad 2-input NOR, and the 4002 being a dual 4-input NOR. So the truth table of the NOR, the output is high if both inputs are low. Every other input combination gives a low output. And that's the same as an AND gate with an inverter on all the inputs. NOR gates can be used to combine together and make any other logic function, same as NAND gates. So that's one of the reasons I want to have a bunch of NOR or NAND on hand. When you run out of specific gates, you can always build your own. I only got 5 of these CD4018 parts for $2.58 US from Orchid. The 4018 is a divide by N counter, but it's pre-settable. You could take something like a 4017 Johnson counter, and it's got those discrete 10 outputs, and you can use that to divide. But if you want to be able to preload a certain count, this type of chip will do that. And you can make this divide by 10, 9, 8, 7, 6, 5, 4, 3, 2. And you can stack them together to get even more division. I don't have a specific thing in mind for this. It's just that it does divide an input clock and give a little bit of flexibility on those jam inputs. So maybe I don't always just want to divide by N. Maybe sometimes I want a certain condition to exist in a circuit where I preset a condition here, and maybe you can actually generate an interesting output waveform instead of just a divided down copy of the clock. For a couple of dollars, it's good to have things like this on hand. Electronic component, and it's really tightly packed, but it feels like it's in a secure enclosure in here. Okay, yes, part tubes. Oh, a lot. And it came with a note. Dear customer, thanks for your order. If you have any question when receiving the package, let us know. Have a nice day. Well, thanks. The only question I have is, what is all this? Is it all the same? So we have quantity 5 in this tube of CD4001. It looks like I was ordering a lot of CMOS digital logic, restocking. Quantity 10 of 4013. Quantity 10 of, I think, NE556, the dual 555. Quantity 10 of, 74 series, 74HC04. And quantity 10, 74HC14. 10 pieces dual precision timer ICs, 556, dual 555. 10 for $199 from E Come On 2013. So basically you're getting 20 555s through the 10 dual 555 package. So these are useful to save space when you have a circuit that does use multiple 555s. I've seen certain sound generators that do this. Back ever so long ago, I had a lot of 555s and a lot of 556s, as well as 741s and some common logic gates kicking around. So I wanted to rebuild that collection. So while I was ordering the 556s from this seller, I also got a whole lot of other stuff. I got 10 pieces of 14-pin DIP 74HC04 Hex inverters for $2.99. You can never have too many inverters, and you can never have too many Schmitt-TRIG Hex inverters 74HC14. Also, 10 of these are $2.99 from E Come On 2013. So we won't do a lesson on what's a Schmitt-TRIG here, but the difference between a regular and a Schmitt-triggered logic gate would be the inputs are more immune to any noisy signals because they use two different switching thresholds, one to tell when you've gone high, one to tell when you've gone low, instead of a single, more central threshold where if you're above it, you're high, and if you're below it, you're low. So if you've got a lot of noise on this signal as it's rising, and you trigger the upper threshold, you're going to need a lot of noise to trigger that low threshold, instead of just having a single middle point that you're easily re-triggering high-low, high-low. I've had a few projects recently where I used a 4013 CMOS dual D flip-flop. Now I've got 10 more of these to continue restocking for $1.89 US from E Come On 2013. I think I only had 2 of these part packages sitting around when I was looking for them, and I like the idea of having more on hand in case I break one, or if I need to do multiple projects and I want to keep them all assembled. And everyone needs NOR gates, so I bought 5 pieces of CD4001 2-input NOR gate. $2.18 US from E Come On 2013. Well, that's a lot of parts. I'm going to have to start thinking of some projects for that. This one contains some of my most favorite things to get: a digital voltmeter module, a plastic patch, and an expansion board module. I cannot wait to see what's really in here. All right. So which one of these is the plastic patch? Well, this looks like an 8-pin surface mount to 8-pin DIP expansion board, but it's only single-sided with only one style of pitch surface mount part. Those other ones I have a finer pitch on the other side, but that's fine. 20 pieces of SOP8 breakout boards to through-hole, 99 cents US from Alice 110 1983. There's several different surface mount breakout boards available, and this time I chose the SOP8. I've got several of these other ones as well, and I do have some chips that I've ordered I'm still waiting for that I'll be able to use these for and start breadboarding some surface mount parts. Power, ground, V-in plus and minus, V-ref, V-out, 3.3, ground. It has some sort of a trimmer pot looking thing. It kind of looks like some sort of op-amp circuit, but I don't have my magnifier right here, so it's easier to just look this up. INA 333 low power precision instrumentation amplifier, 3 op-amps, multi-module. $3.94 from Alice 110 1983. When they say 3 op-amps multi-module, what they mean is the instrumentation amplifier chip has 3 op-amps in it to form the instrumentation amplifier, of course. And I figure this trimmer pot here sets the gain. And I'm not sure, I guess this looks like a voltage regulator. So looking at the description here, this looks very familiar to this from the datasheet. And a single external resistor sets any gain from 1 to 1000. Supply voltage can be 1.8 to 5.5 volts. High common mode rejection ratio, which is the advantage of the instrumentation amplifier structure. Here's the 3 op-amps, and just one external gain resistor controls the whole thing. The reason I wanted this is to just try some experiments similar to some of these, like a bridge amplifier, pressure sensors. It's good for picking up tiny signals and amplifying those and eliminating any noise that's common to both wires. So if you have a faint signal, either because it's a small signal inherently or because there's a lot of noise and it's hard to see the signal itself, using an amplifier structure like this will clean it right up. Lots of ICs to work with and restock and come up with new projects, because lately I've been noticing I've run out of chips and I just need a basic stockpile again. So this is a good head start on that. We have an expansion board module, some surface mount to dip breakouts, some infrared stuff, some toroid cores for future inductor winding experiments. Overall, a very good practical shopping spree has occurred. So all of this over the next while is going to be definitely put to use.